All right. Thank you very much, everyone, for coming. Today, we're going to talk about how artificial intelligence can help you, as a developer, find horrible things before you hurt the people you love. And horrible things, we mean application security bugs. So how many people in the audience have ever written a bug? Okay, we've all been there. We've all written a bug. How many of us have ever written something that turned out to be a security bug? I have. All right. What kind of thing was it?
It wasn't actually code. It was the way our customers came to us and the way they described the security groups.
Ah.
And it didn't leave single responsibility based on the requirements they gave us, and we found out it was a lie later on.
So it was like a configuration bug, right? So it was a simple oversight. Anyone could have made a configuration bug, something like that. You know, I've made mistakes too where I'm like writing code and I'm like, oh, I am supposed to really keep track in my head of how things work, and I overlook things just like you overlooked something. And it turns out 84% of attacks happen because of issues like this. So the question is, what can we do to help you write code faster without making those kinds of mistakes? So last year, we introduced artificial intelligence for finding application security flaws. We call it Microsoft Security Risk Detection. So what we do is we bring some of the same work we've been using to make Windows better, make Office better, make our own products better. We bring it to you as a cloud service. But what we did last year, it was very manual. It was something that you would sort of manually log into a machine and you'd fill out a wizard and you'd get some bugs back. What's new this year is we've integrated with Visual Studio Team Services and with Azure Logic Apps. And that's what I'm going to show you today. I'm going to show you how you can start testing straight from your build definition, and you can test as many times as you want, as much as you want. If you want to test on every new pull request, you can do that. If you want to test every week, you can do that. And what we do is we bring all of the artificial intelligence we've been working on to help find horrible flaws in our code and fix them before we hurt the people we love, that is you, and we bring it to you. And you'll see how to integrate it into your workflow using the power of Azure Logic Apps. And we can do this over and over and over again. So enough of the slides. Let me sort of show you what we're talking about here. I'm going to show you a small application. This is a sample application. All this code is on GitHub. You can go download it right now. This is an application written in C++, which is horrendously dangerous to write code in, as we all know. And we have planted 10 horrendous bugs in this application. You can go through and find 10 buffer overflows, integer overflows, horrible things that will destroy your computer and let other people take over everything in your data center. And we've put them in here for you, just for you, and documented them all. So I've been able to check this out, and I have this wonderful piece of code. And you know, what does this all do? I don't know. I could sit here and try to read it for you. I could sit here and try to read it to find those 10 horrible bugs. Well, actually, spoiler alert, we've actually put in comments that explain to you where the bugs are. So this gives you an idea of the kind of stuff we can find with this AI technology. This is a case where we just forgot to check the length of a string before we copied it. Happens to everyone, right? I see some people nodding in the audience. Now, last year, we showed you how to upload this to the cloud and manually fill out a wizard saying, attack this code using our power of our AI. And with that wizard, you could get a list of test cases that cause the crash that show you where this is. But this year, we can do something even more fun. There's no more wizard. There is only Visual Studio Team Services. So what we've done is we've put into our build the ability to kick off a security testing job. I'm queuing a new build up there. And then what happens is, after that build happens, we can send events saying something new has happened, something new testing has started, a new bug has been found. And what happens to those events? Those events go into Azure Logic Apps. So let me show you what that looks like. So this is a list of Azure Logic Apps. And I'm going to get a new app that says, all right, Whenever something has been created, a new testing job has been created, something might happen every week or every day, you choose because you put it into your build definition. If you feel like this should happen every day, you can do that. On every pull request, you can do that. I can say whenever a request is received, I want to send an email. And I can say, all right, what happens there? I want to send the email to me. So I can send it to dmolnar@microsoft.com here and send all the information. And that looks like this. And all you get is a JSON, which then you can, of course, turn into something more interesting. You can create your own logic on top of this and say, look, I've got a new test case. It started. Here's where it starts, when it starts. And I can then link that back straight to a web portal we have, which shows you all of your tests as they're being done. And you can go back and say, what's the status of all of these? What's happening with all of them? So if I want more, I just add a new step here. So let's suppose I want to annoy the hell out of everyone on Teams when something new gets tested. I want to put everyone in my entire organization on notice that we're testing them for security flaws. Well, that's really easy. I just go ahead and say Teams. And I have a connector here. And I get a list of actions. And I can say, I want to post a message. And I can say, all right, what's the unique ID? Who can I bother today? Let's see there. I need to bother Springfield. Right. I need a team ID first, of course. There we go. That's our organization. And I'm going to bother them with this. And I can completely include the body of the message, which is all the data about the security testing. So in this case, I'm showing you the event that happens when the testing starts. But we also have an event for when we find something that can tell you a link to the test case, a link to all the details. You can then put that into your workflow and say, how do you want to handle it? And I'm like, great, I'll save that. And what that looks like, well, that looks like this. Whenever something happens, we end up getting an event posted to the teams, which allows you to bother everyone in your organization and let them know something is happening. Or you can write code on top of this that says, whenever I find something really critical, I want to alert people in Teams. I want to alert people, through email, and then make sure the right people sees it at the right time. So we've gone from something where you had to go to a website to use our special AI to having it disappear into your build process. It becomes something that you can just add as another step. And something that becomes as simple to use as just going through your build definition. So this is the build definition that we're using here. And you can see it starts out just like any other build. Use Nugget, build the solution, get the assemblies, publish symbols, publish a drop. And then we copy the files up to Azure because our service copies the files from Azure and in order to start working on them. And then you can say, I want to just run Microsoft Security Risk Detection, which is our service, on that code. And this is just something that and you can see here, the build has succeeded, and we end up getting a new build of the application, and we end up sending information to our service, and our service sends information back to you. So we're giving you the flexibility to define how you want to manage security risk. You decide who to notify. You decide when to run it. You decide what to integrate with. So we go back to Microsoft Flows. I've got this. I'm saving this. But there's actually over 1,000 other connectors. 1,000 other connectors, and more being added all the time. If I want to just connect it, I say I want another action. So for instance, if I want Visual Studio Team Services, you can see here there's the email. I showed you the logic flow, and there's the email coming to my inbox saying something has been found. Now I can go to Visual Studio Team Services. I want to create a work item. And I can say, great, I can create a work item whenever an issue is found. I can use the information I know about the build to assign it to the responsible person. And after I assign it to a responsible person, I can email their manager to make sure they actually do something about it, and generally create a reign of terror. It's great. And so this is all of the things that you need to just fill out right here. Or I don't actually have to be restricted to the Microsoft ecosystem. So I showed you Teams because that's what I happen to use myself. I'm at Microsoft. But we have a connector for Slack. So how many people here are using Slack? OK, about half of you are using Slack. No problem. We can push to Slack. How many people are using Jira? OK, about half of you. We've got a connector for Jira. And if there's a connector you want and we don't have, you can go to user voice and ask for it. You can actually create your own connectors. So how many people here have heard of Product Studio at Microsoft? OK, one or two people. We have this thing that we use inside Microsoft called Product Studio. It's obsolete. Everyone should use Visual Studio Team Services. But if I wanted to build something that connects from Logic Apps to Product Studio, I can do it. I just have to write a service myself that speaks the specific contract that this is expecting. That's it. So if you happen to have a homegrown bug ticketing system, or 2, or 3, or 10, you can still use this to create all of the automation and logic for handling the security bugs, and then connect it to whatever horrendous thing from the 80s might be lurking around in your organization. Because I certainly have that too. So that's how we end up sort of connecting you to our artificial intelligence and having it disappear into your workflow. Now, what I want to do is just go back and explain a little tiny bit before I wrap up around what it is that we're doing under the covers. So this is a way of showing you all the different things that we're testing at once. You see here we're using Windows for operating system image, but we are here to meet you where you are. So how many people here write Linux applications? OK, a few people. We support you too. We can test you on Linux. And in fact, what we've done is we've been able to take our artificial intelligence, our cloud AI platform, and extend it to Linux. What we've done is we've taken something called neural fuzzing. So this is part of our continuous effort to improve the research and the state-of-the-art in security and artificial intelligence. And we bring it to you. You can use this right now, today. Our goal is to let you throw millions of test cases at your code to find horrendous corner cases, to find security vulnerabilities. Now, previously, there's a lot of different ways to do this. The word fuzz testing starts in a dark and stormy night in Madison, Wisconsin in 1989. It's called fuzz testing because Professor Bart Miller was actually dialing into the modem pool. How many people remember modem pools? OK, so you remember line noise? You remember how when like the lightning happens, all this crazy stuff happens on the line? He noticed that his applications would crash. And he realized like what nature could do, he could force a grad student to simulate. So he went back and made all his grad students write lightning simulators and attack common utilities of the time. And now we have all these different methods of doing fuzz testing, which our platform continually improves and continually integrates. And our hypothesis was that we could make this better using the power of deep learning. So we originally worked on several methods of deep learning for speech recognition. So if you go and you take a look at the Microsoft Translator booth here on the show floor, you can see people doing real-time speech translation. You may have seen the discussion earlier with someone who's deaf talking to someone who speaks Mandarin. That same technology, that same deep learning is now available to you in Azure. You can use the Azure AI Batch platform to train your own deep learning. And that's what we do for this fuzzing. We realized that if we took a look at some of these classic methods that people use for doing security testing, there's a random step where people are rolling the dice to figure out what to attack next. And we realized if we could figure out how to change that random step into something that uses deep learning, we might be able to find more bugs for you faster. And we can. We can. We use Azure AI Batch. We use TensorFlow because Microsoft is here to meet you where you are, to help you, the customer, no matter what kind of artificial intelligence you need to use. We're here to enable every person, every organization on the planet to achieve more. And what we are able to do is after a 24-hour run of the existing original security testing mechanism called AFL, it's open source, you can all go look at it. We were able to train using Azure AI Batch in 12 hours and come up with a model that gave us a 62 times increase in the number of security crashes found. 62x improvement by using deep learning. And what we've done is we've taken this and we're using Azure AI Batch. This is actually a screenshot from our diligent developers who are working day and night to put this together. You can see that we have a training Azure AI Batch there as part of our resources in Azure. And this is one of our clusters waiting to start training, waiting patiently to get ready to take on your code to go after your information, your security bugs. And we're able to get 62x improvement. And we're putting this into the product so everyone can have access to it. So that's the long and short of what we've been able to do. I'm coming to the end of my time. I am here for you. I can answer all of your questions right here after the talk. But the next steps. We have a website you can learn everything you might want to know about Microsoft security risk detection. Our way of bringing what we learn about artificial intelligence and security to the entire world. You can sign up today. You can learn about neural fuzzing, which builds on top of the best that Microsoft has to offer in our cloud AI platform. And you can learn here at Build. You can be the first to learn about all the fantastic possibilities that you can use to get 62x improvements of your own. And that is the whole value of becoming a Microsoft Cloud AI developer. So to recap, we bring you AI. It can disappear into your process. It can make you a 62x hero, and you can learn all about it here at Build. Thank you.